Hi, welcome to everyone's favourite segment, Mailbag, where I open my mail. Couldn't resist starting off with this one. This one is from someone who pretty much, well, at least all the old timers in Australia will know, the Don McKenzie. From Electronics Australia fame, Dontronics fame, he's written many articles and of course has been selling like online kit, embedded computers and all sorts of stuff for, well, longer than a lot of you kiddies have been alive. So apparently he was one of the first people in Australia to own a personal computer, like a commercial personal computer. So yes, Don McKenzie from Dontronics, very famous in Australian electronics industry, an absolute legend. So this is from Don McKenzie from Tullamarine in Victoria. Hi to all my viewers in Tullamarine. And this could be anything, because like Don is like his online store, Dontronics. He was the first person in Australia to, his first business in Australia, I believe, to take online payments back when the internet was, an early thing. The first person to ever do that, I believe. Anyway, so he was the first to sell all sorts of microcontroller and embedded products and stuff like that from his store, Dontronics. Anyway, if you want to send something into the mailbag, if you're a company or an individual, you want to send something interesting, and I open it here, send it to EEVblog mailbag. Got to put mailbag on it, otherwise I'll open it before it gets to my mailbag bench here. Because I order a lot of stuff. Stuff turns up. Dave Jones, oh yeah, open it. What is it? What have I ordered that I've forgotten about? Anyway, EEVblog mailbag, PO Box 7949, Norwest, New South Wales 2153, Australia, not Austria. So, thank you very much, Don McKenzie. Like, what is in here? There are 2 boxes. So I could be anything. Could be anything. We've got a, I'm pretty sure that's not a mobile phone inside that box. Hope it's not fragile. Oh, we have a note. Oh, hang on. I've got a whole bunch of, original Dontronics stickers, dontronics.com. I just had a quick check, and his website, it's still all there, but now you have to get in and go to HTML links and stuff like that if you want to see the old website, and I'm pretty sure that is not a router either. So let's have I'm going to open these. I'm not going to read the note. Sorry, Don. Well, I will, but I've got to open it first. So it could be anything. Like I expect, yep. I expect a bunch of random stuff. And, oh my goodness. Oh, these could be like original. Oh, hang on. Oh, beautiful. That's like 80s, 90s vintage smell. Oh, fantastic. Oh, what have we got here? Hang on, I have to put the Googles on. Oh, check it out. Look, we've got... I'm just going to have to show you these all up close, but we've got ZIF sockets, we've got USB PIC programmers. Who did that one? Because I had an original, oh God, I can't remember now. J. Gordon Electronics Design Inc. We've got, these would have been like all boards that Don has sold over the years, I'm sure of it. And original, just random prototype hardware and stuff. Oh, one of his original PBUFF prototypes. Because one of the things that Don is famous for is the printer buffer, or PBUFF as it was called, which plugged into your Centronics printer port, and it would buffer your stuff. This is back before like Ethernets and all that sort of thing. It would buffer your printer so that your PC at the time would think that you've actually printed something. You haven't. It had like a couple of meg buffer on it, I think. And I designed my own simple one like early back, but it wasn't nearly as good as the PBUFF, nearly as advanced as the PBUFF here. So there's a whole bunch of old projects. What's in here? Anyway, so yeah, that was a very popular project. I don't know how many tens of thousands he would have sold of that, but it would have been a lot. Yeah, more. So let's go close up on the bench. Hello, Dave. Some time ago you proposed the idea of conducting an interview with me, but I declined. Why? Fear of facing a video camera and apprehension about public speaking. A lot of people have that. It's very common. Quite a few people have turned down my interview requests over the years. Recently, individuals like Riley Perry, creator of the Australian Computer Museum Society, and Carl von Muller, mate of mine, convinced me that I don't document these stories now, it will fade into obscurity. So he took the plunge. So here we go. Here's a brief overview of some of my potential milestones and accomplishments. Yeah, the PBUFF printer buffer, 4 meg of DRAM, Z80 processor, had no physical address decoders, all orchestrated through software, and a couple of TTL chips. And I think he wrote an article on how that worked as well. Read-write routines and source code available for verification. Sold over, there you go, 4,000 units before the advent of the internet. And printers that actually had decent buffers in them. Yes, pioneering online real-time transactions, one of the first online shopping carts, electronic website, and the SimStick, of course. That was, ridiculously popular, 50,000 units. Yeah, the SimStick design contest, I remember that. Developed Department of Communications Morse code receiving test generation until he terminated the contract. That's interesting. Pioneered many online groups, which I was a part of course, back in the day. Yes, the Australian Electronics Web Ring. Leave it in the comments down below if you remember web rings. This is before search engines. How you found other electronics related sites is that we'd all join this web ring system, and so everyone had this Australian Electronics Web Ring thing at the bottom of their website. I don't know, does my website still have it? Oh, maybe somewhere on some old page. And it would link through, so you press next and it'd go to another Australian Electronics website. It was absolutely fantastic. But he founded PIC and AVR groups, and he wrote many articles, of course, for EA and Silicon Chip and other magazines. Arguably purchased first personal computer sold in Australia, March 1978, now proudly housed at the Australian Computer Museum Society. Awesome. Consulted to the ATO regarding GST rules. Yeah, I remember that. Back in the day when Australia introduced our goods and services tax here. It was an absolute shite show. And they famously didn't know what stuff was GST included and how to implement, and it's all horrible. Anyway, Don had a hand in sorting all that out. Fantastic. He consulted for the Victoria Police Forensics. He was the main man knowing about PICs, and he's dispatched a box of treasures to me. Before December 95, I operated under the name Don McKenzie, transitioned into Dontronics. Thereafter, the age of the boards reflect this shift and generally can be discerned through overlay, text, silkscreen. Yeah, we'll see the progression in technology in the PCB and solder mask and plate throughs and whatnots. I believe the standout item is the PBUFF board. Additionally, there's a rather ugly, very rough PBUFF front panel. That's what that is. Initially deemed disposable, but I recognise its significance as a first prototype and perhaps worth preserving, especially considering it should be a match to the PBUFF I sent. Following closely are SimSticks. Customers worldwide have entrusted me with their innovations through time constraints, although time constraints prevented me from fully exploring each one. Fortunately, much of the documentation predating 95 has been lost. A bummer. And I'm endeavouring to retrieve it. You'll find a blend of old and new boards alongside intriguing items sent from various corners of the globe. Is included a postcard crafted by Mick Gavelson, a PCXT, and if memory serves me right, the PCAT featured, the power on self-test diagnostics, which was used to troubleshoot clones. I had one of those post boards back in the day. You plug it into the ISA slot and it'll give you power on self-test error diagnostic codes and stuff like that. Very handy back in the day. So I'll link in 32v8.com/D down below. So let's take a look at these boards. So here's the PBUFF or printer buffer board. I love it. It's double-sided playthrough though. Look at that. Oh, fancy pantsy playthrough holes. Amazing. So we're going to, Z80 CPU, date code 51st week 88. So there you go. That's, it looks like it's missing its DRAM though. But the thing about this is that he did all the DRAM addressing without, with a couple of TTL chips or something like that. So, I believe that's flapping around in the breeze. That poor regulator's, that's Kamagutsa completely, I think. Oops. Yeah, but I do believe he's done a article explaining, I'll see if I can link it in, but I don't know, it might be hard, explaining like how he did the trick of the memory addressing for the Z80 using so very little hardware. Anyway, yeah, very cool project, sold many thousands of these things, and this is of course before printers actually had buffers in them, but there it is, Don McKenzie, original PBUFF prototype. Oh, fantastic. I love the hacks on the back too, and the resistor array. Great stuff. And just random boards, we just jump forward. It's a USB Pick4U Plus, micro4u.com. So that would have been a pick programmer. I had a Newfound Electronics pick programmer. That was my first one, which was, yeah, Newfound Electronics. I think he was in Victoria too, if memory serves me correctly. And yeah, that was a fantastic early pick programmer, and he wrote all the software, software and firmware and everything for it, and it programmed pretty much every pick. Well, back in the day, when there weren't the huge selection of picks that there are these days, and yeah, that worked very well. So that was my main pick programmer for donkey's years. And Don made and produced a whole bunch of like slim SIM slot compatible prototyping boards. This one's got for an Atmel Micro here. It's got an RS-232 interface, the DT014. Leave it in the comments down below if you've ever used any of these bad boys. DT023, larger versions for, I don't know what that one's doing. But anyway, tons of these SimStick form factors. And there's a PBUFF user interface. It's not like there's no labeling on it or anything. Toggle switches and some push buttons here. Oh, there you go. That's all fancy-pantsy, isn't it? And that would hook up and talk to the PBUFF. Oh, my goodness. Old school parallel interface there. Oh, crazy stuff back in the day. But, that's all this microcontroller rubbish. And that was only the small box. Look at this big box. Look at this SIM parallel. Yeah, it's completely parallel. SIM module, like parallel SIM interface, because he had all these SimStick boards which used the SIM socket, of course, as an interface for a do-it-yourself platform. So, which had various micros and whatnot. That's a more modern one. JeffG.net, Olimex. It's a Ken Segler Designs there. So, what's that? It's a Testamite. A Testamite. I don't know, for testing something. Testing some micro interface kit. Oh, that's for the Maximite. Right, yes, I've probably done a video on the... Have I done a video on the Maximite back in the day? Which was a PIC-based Arduino competitor kind of thing. And that was really groovy back in the day. What do we got here? Oh, geocities.com. Look at this. Hands up if you have the GeoCities site. That looks like a PIC programmer, another PIC programmer design there. Oof. Lots of people doing them back in the day. And that's a PIC-Me. I don't know what a PIC-Me is there. PIC16C5X. Is that another PIC programmer? That's another, it looks like. That's possibly, I love how it's a single-sided design layout there, none of this double-sided rubbish, because single-sided, if you published a project back in the magazine back in the day, if it was a double-sided project, it was really hard for them to publish it and for people to make their own boards, because they'd still put the PCB overlays in the magazines back in the day, so that people could take a photocopy and actually etch their own boards and stuff. So I did a logic analyzer. I published in Electronics Australia a huge was it 32 channel logic analyzer, and it was a single-sided board. I'm sure I've done a video on that. Yeah, so I made sure to squeeze it onto a single-sided board just so that people could actually make the thing. mmbasic.com micromite interface. There you go. So this wasn't Don's design, because he was a big online retailer back in the day. That's a jeffg.net. Yeah, so that's part of the Maximite thing. So a micromite is an add-on for the Maximite thing. Oh yeah, the backshed.com forum. I think that might actually still be going. I'd have to have a look. And what is this bad boy here? A bunch of 74 series logics. It's a PPEX. That's a Don McKenzie original. Made in Australia. Fantastic. Input, output. So it's another prototype of some description. I don't know what that one's actually doing. It's not a printer buffer thing. It's got no memory on it. It's just got discrete digital logic. So it's doing something. It's not doing something that intelligent that it needs a microprocessor in it, like the Z80 on the PBUFF. The Donduino converter board. The Donduino Cross. Look at that. That's really groovy. That's some cross-switching matrix thing? That's very interesting. Just more random projects on these SimStick boards. So hands up if you used Don McKenzie's SimSticks for your project, like form factor back in the day. Another one there, RS-232 interface with external power adapter. Oh wow, that's a USB sim board. So that's a SimStick, like USB interface for the SimStick. Wow, I did not know that the SimStick had a USB interface on it. What processor is that going on there? Sorry, can't read on the camcorder screen here, but that's interesting. I didn't know that there was a USB interface for the SimStick. Wow, that's groovy. That would have been advanced back in the day. Of course, that's probably like USB 1.0 or USB 1.1 or something like that. And as mentioned, there's one of those postcards, one of those power-on self-tests. You plug it into the PC ISA slot here. They couldn't spring for the gold flash on the edge connector, but that's good enough for Australia. And that's a Mick Golofsson design there, and it would put, so you'd plug it into the PC, you'd start it up, and it would put error codes here, or codes that you could diagnose where your machine is hanging at, or whatever, diagnose the startup process and figure out what's wrong with it, because your latest your latest plug-in board design didn't work and it's hanging somewhere and you wanted to diagnose it, or your PC was just dodgy back in the day. You wanted to diagnose it. These post boards were the duck's guts. I had a much bigger one with a big ribbon cable that went off to an external LED display so that you can have it like outside the box. There's an original business card for J. Gordon Electronic Design Inc. There you go. I wonder if the website's still there. That's another jeffg.net design there. So that's a gum, I think it was pronounced gumstick type design. So that's a little micro SD card, and is that a little pick ski down in there? That might be a pick. Then we've got this interesting looking proto board here. It's a Scorpio design. Copyright 2001, so that's relatively advanced we're talking about here. So yeah, Don was a distributor for like a ton of different people. You know, if you design your thing back in the day and you want to sell it on the line, then a lot of people would send them into Don, and Don would evaluate them or help finish off the designs or whatnot, and sell them on his one of the first online stores that had these things, until, you know, now you just take it for granted. But, you know, back in the day, it wasn't easy to get stuff. So thank you very much, Don. That is a very interesting collection of prototype boards. And yeah, I remember a lot of this stuff. And of course, Dontronics back in the day, absolute legend. Thank you very much. Don is still going. So I'll link in his website down below. Thanks, mate. Got one from the United States of America. Thank you very much, David Keck from Santa Clara. I've been to Santa Clara, in California, of course, but unfortunately California is just going right down the toilet. Leave it in the comments down below. Anyone still living in California? Are there still U-Haul trucks left? I'm not sure. Anyway, a toaster. What is a toaster? It's a toaster. I would guess that a toaster is like a little mini VGA reflowy thing. Oh, hang on. No, it is. It's flashing. It's flashing. Have I been a toaster? Okay, it's got a camera on the front and Did it just activate when I opened it? Photon. Okay. Thanks for buying Photon. Okay. It's a little like GoPro-y. It's really like die-cast case. It's really quite schmick, but it is flashing on the front. So, it looks like we've got schematics, STM32s for all the fanboys. Hey Dave, long-time fan, I designed this camera after someone kept trying to steal my motorcycle in an apartment garage. It is a motion sensor and long battery life. Aha! Greater than 50k photos on a single charge. Perfect for catching a motorcycle thief. It's rainproof, but I removed the RTV sealant on the backplate so you can open it up easily. Nice. Software is open source, but Mac only for now. Oh, boo-hoo. The software is available here as like a little SD card inside or something. Can I take it out and have a look? Well, technically I do have a dumpster Mac somewhere. There you go, it's probably taken a photo of me. So, I presume, yeah, motion activated, takes a photo every second or whatever to catch fees. Cool, let's check it out. I so wish this wasn't Macintosh only. I do have an old dumpster Mac, but it's got the old High Sierra operating system, and apparently this one needs 2 generations newer than that. So unfortunately, I can't actually use this thing because I don't have any Mac to actually load the software on. That's a real bummer because like USB-C, why can't it just like the SD card just save JPEGs on there or something and remove the SD card? Anyway, I'm going to see if this thing suddenly turns on when I switch it, because it can do up to 50,000 photos on one battery charge. Yeah, it's not. Yep, it just instantly came on. Yep, it just detected that I opened it, and I have tried it before, and yep, it's doing that. So, hi. So yeah, we have a passive infrared sensor here. I'm not sure what the switch does, but obviously it's going to flash the LED every time it takes a photo. Got a 130 degree lens on it. So maybe I can open it. Let's definitely open it up and access the SD card and see if I can get the files in it or something. But I don't know, is it some Macintosh format? I don't know anything about Macs. Got no idea. Anyway, it's a beautiful case, die-cast alloy. It is splash-proof. It's not completely waterproof, but you know, splash-proof, pretty decent. And as I said, 50,000 hours. I'll put up like all the different features and specs of the thing here, and it really is quite something. I could actually really use this thing if I can read off the SD card or something like that. So yeah, like especially like you could use this as a security camera for like an infrequent thing or something like that, and it's got no built-in Wi-Fi, Bluetooth, anything wireless, so it cannot be hacked remotely, doesn't upload to the cloud, none of that cloud rubbish at all. So the only way to access the files is to physically plug into the USB-C on the side here, or I guess maybe open it up and take out the micro SD card. So yeah, let's crack her open. Yeah, well, there we have it. It's all lithium polymer battery, and there's some rubber around there to make sure it doesn't bounce around, but let's get that out. There you go. That comes out nicely, and there's the back of the board. Yep, we can access the SD card inside this thing, and the black solder mask, bugger. Anyway, he did provide the schematic with it, so that's very nice. Just like a battery connection there, and Bob's your uncle. And it uses a, looks like an ARM processor, but it does have an FPGA and an MSP 430, I believe. Let's go to the schematic. And there's a nice programming header down there too. Beautiful. So I won't go into huge detail on the schematic, but we've got a whole bunch of power rails here. Of course, you know, modern electronics need a whole ton of different power rails. Got the battery charge circuit, battery reverse polarity, nice. The battery charging is a microchip jobby. Then we do have an MSP 430, so all the MSP 430 fanboys are going wild. Well, that's just like doing all the low power standby processing and stuff like that. It's only when it boots up does it actually, I get, maybe Yeah, no, because they had an arm thingy in it. So anyway, that's just a LED, button, USB connector. There's the motion sensor. It looks like he's a real fan of like having these on all different pages. I don't like that. I'm not a fan of that. Please lower the number of pages. Yes, it's got an ICE40 FPGA. There you go. Yes, that ARM processor was an STM32F. But anyway, on the other side of the board, that's our image sensor there. Image sensor processor, we've got some SD RAM there, and the SD card, hang on, oh, there it is, there's the STM32 on the back there. So we've got an STM32 ARM processor, we've got a MSP430 to do all the low power stuff, so I guess the STM32 wasn't low power enough? Anyway, and an FPGA. I think I might know what's going on here. The STM32 is probably doing all the Macintosh interfacey doodad thing. And I'd imagine, yeah, that only powers up when you plug in the USB connection. And I'm going to guess that the SD card actually goes into the FPGA, which then goes into the MSP430. So the FPGA would be reading the data from the sensor, and then the MSP430 is controlling that. That'd be my guess. Yeah, you can see that the MSP430 here is handling the motion sensor stuff. There's another image SD enable up there, something like that. Button, battery chirp, yeah, so the ICE40 FPGA here, yeah, as suspected, it's handling the RAM here, and it's handling the image sensor. So yeah, you want that to be, because those ICE parts, it's in the name, ICE. Low power, they don't generate much heat, get it? And yeah, so it's a low power FPGA. So that's how it gets the incredibly low battery power, and you probably can't do that with the ST processor, even though the ST processor has, probably half a dozen different low power modes or something silly like that. But yeah, the way to do it is to have the RAM connected to the FPGA, the image sensor connected to the FPGA, and then that being ultimately controlled, although it's probably got like a state machine in there to read from the image sensor and store it straight into RAM, because there's no data processing. That's right, it's raw images, so there's no JPEG processing, I don't believe. I think it's raw images being dumped directly from the sensor over to the RAM. So if you're a fanboy of that, like, you don't lose anything, you don't lose a single pixel, it's straight over. But that could have issues with what's on the SD. And yes, it does go over to the SD card as well, by the looks of it. There. So maybe, I don't know, let me get the SD card out and see if I can read anything, but I don't think it's going to be a JPEG. I think it's going to be a raw image file at the very least. No, unfortunately, I couldn't read anything on that on my Windows machine. So, yeah, I'd like to know, please, add Windows support, or add maybe, I don't know, add a button, you do something with the button here, and then it translates all the images or something into JPEGs, or even into, like, raw image files, something that's readable from the SD card, because I don't mind taking off the back cover, because, like, if you put this in some, long-term security installation or something like that, that gets, not much motion. Like 50,000 photo battery life on this thing, it's absolutely incredible. I think he might have hit a real niche here, and it's only 200 Yankee bucks, designed and made in the United States of America. Might have hit a real niche here. It's open source, it's rugged, it's cute, it does one thing and seems to do it well. Hopefully does it well, and I'm sure it's, I'm not sure what image sensor in there. See, it's still taking photos, if no, I don't. Is it still taking it to RAM and then dumping it later? Hello? No, it's not taking anything anymore. Well, there you go, hold down the button, it's doing something. It's resetting. I don't know. Have to RTFM. But anyway, I think this is very cool. Thank you very much, David, for sending that one in. I'll link it in down below. There could be a really good niche market for something like this. Not a jack of all trades, masters of none, but a tool specifically for ultra long battery life, and presumably, you know, you could power it from the USB externally as well if you really wanted to. None of that Wi-Fi rubbish. It's unhackable. You've got to physically get into the thing to get the images out, or plug it into your Macintosh. But yeah, please add Windows support. That'd be absolutely fantastic. I think this is really cool. I like the premise of it, and it seems well executed. So I'll link it in down below. Shame I just can't test it right here for you now. Need a bloody Mac. Hi to all my Canadian viewers. Thank you very much, Michael Reddin from good old Canada. Is that a note? That's not a note on the top. I thought it was. There is a note inside. I won't read that yet. Let's have a look. Wow, it's a lot of padding. Can reuse that. Oh, this looks vintage. This looks used. Wow, look at this. This is a 4-banger Sanyo mini calculator. Mini. In quote marks. Oh, vintage. Convenient carry handle with your mains cord on it. Fantastic. Wow, I've never seen that before. A Sanyo 4-banger, which is what we call in the vintage trade as a 4-function calculator. Oh my goodness, that is just, I don't even know what to think. It just looks like a portable transistor radio, does it not? It's just crazy. Check it out, the Sanyo mini calculator. It's got, whoa, look at that, constant memory by the looks of it. Very fancy-pantsy, and I swear it looks like an old transistor radio for you young kiddies. You have no idea what I'm talking about. Made in Japan, all the best stuff's made in Japan. It's the ICC 811, draws 4 watts, 120 volts, so let's actually power it up. It's got their weird Yankee plug, so let's power it up and see if she still works. And on. And it still works. Oh, that's a beautiful orange there. Look at this. Oh, beautiful. 3.1415926.5. Look at that. Okay, but we can't go the extra digit. Oh, no. It's a very interesting 4. Look at that. It's got that little bit on the right-hand side there. Wow, that's pretty neat. So, look at that. Wow, seems to be fully functional. Neat. And I assume that's like constant memory like that. So, how do you recall, is CK? No? Oh, there we go. He's got an overflow there. Comically long screwdriver time. Let's go. With the size of this thing, it wouldn't surprise me if there's a ton of discrete logic in this. We don't know a date code on this, or at least I haven't looked it up. We got something under the feet here. No, it just snapped off. No, got a couple of plastic tabs. And ta-da! Oh, there we go. Oh, look at that. Wow. Gee, oh, geez, that, look at that. Look at the physical construction of it. Oh my goodness. But we do have a single chip solution. Check it out. We've also got the classic foam that disintegrates. Yeah, yep. Yeah, that's classic for old school stuff like this. But look at this, discrete wiring over here. They've put some gunked that down there, so a bit of strain relief on the cables. It's fused. Nice, but oh man, look at this. Wow, look at this densely packed through hole. Looks like a double-sided jobby here. Sanyo branded. Of course, Sanyo made their own chips back in the day, but that looks like looks like 2 Toshiba jobbies there, but end-on diodes, end-on resistors there, and classic large ceramics there. Is that doing all the like keyboard decoding? It looks like it. Oh boy. And this folded metal heatsink here for this power transistor. Oh my goodness. That is hilarious. Anyway, it looks like there's some sort of like hybrid jobby there. Not sure what's doing there, but can we get that up and have a look? There you go, Hitachi chipset, HT3276P. Oh, interesting. Got another Hitachi chippy down in there, and it's just a whole bunch of power supply stuff over here, but look at this. I mean, it's just a dog's breakfast. It really is. Got the mains coming in here. It's snaking right under here with all the keyboard wiring going over to here. It's going over to this transformer over here. Yeah, that's just a diode bridge there, and we got that coming out, and then it jumps all the way back over to here. I mean, oh my goodness, no thought given whatsoever to like construction. Anyway, this is interesting. Anyway, the display is very interesting. I love these little custom plastic brackets here. It seems like they went to a lot of effort there and then just, well, didn't bother with the rest of it, which is a bit of a mess. I won't actually take it apart too much more. I don't want to damage it, but you can see the vacuum port on the back of there for that vacuum fluorescent display. So that is like it's got a really nice orange on it, and it works really well. So there's a close-up look at that vacuum fluorescent display there. It's just beautiful, and oh, I'll power it up. There you go, you can see that gorgeous orange there. Wow, I love that. It's really quite nice after all these years. Maybe it was a bit brighter when it was new, but it's still pretty schmick. Well, I guess that's just what you had to do back in the day to squeeze everything in. We still don't have a date code on this thing, unfortunately. I'm not seeing it. I love the genuine Sanyo cap in here. Gorgeous. But, you know, look, they just went like this bent over, sort of like, it's not really a hybrid. It's not like a ceramic hybrid. It's just like a potted module of several whatevers are inside there, and with, you know, just a single inline pin out on there, and they had to bend that over, and it's just, wow. And like all the discrete through-hole diodes here, all for the keyboard interface and everything else. Oh, it's just, wow. Unbelievable. Like, no thought given to miniaturize this thing at all. So, of course, this thing is on the Calculator Museum websites, and I got two confirmations of introduced in 1972, discontinued in 1974. You got to remember that 1972, that's when the famous HP 35 pocket calculator came out, and that was a scientific jobby that could run off batteries and fit in your pocket, or at least Bill's pocket anyway. But, you know, this was probably designed in 1971, and it was still a thing, and I don't know, it was probably cheaper than the HP Jobby, right? And it seems to imply that there was also a 5 AA battery version of this thing as well. So, I don't know, the mains thing might have been an option, you know, but 2.5 watts, yeah, wouldn't have lasted too long, but maybe you could run it from batteries, but, you know, you can get, it's just a 4-banger, you don't even get a square root. That's what she said. So thank you very much, Michael from Nova Scotia, for sending that one in. That is just, it's pretty gorgeous, actually. And this did actually, when I put it upside down, this thing did fall off, but it does go back on. And it's otherwise in really great functional condition. I mean, we're talking 52 years old here. Incredible. Hi to all my viewers in Japan. Thank you very much. Maeda Kumiko, if I'm pronouncing that correctly. It's something USB something. So some sort of, I don't know, USB dongle-y thing. One of these oddball ones to open. Got a slice and dice. So, need a good Japanese samurai sword for that, don't I? What do we got? Okay. Unique. It's unique. Unique gadgets from Japan. Okay. All right. I guess this company sells unique gadgets from Japan. Look at that. It's got one of those 3D space navigator things. That used to be all the rage back when I first joined Altium. One of the first things they gave you was a 3D space navigator. And because at the time they were just introducing the 3D capability, and the space navigator was the thing that you used. They wanted all the employees to use the space navigator to like spin their boards around and stuff like that. So yeah, if you wanted to know how I did the early intro, if you go back to the very early EEVblog videos, I had a spin-in PCB on there. And if you want to know how I did that, that wasn't animated, or well, that was Dave animated, and that was me using the space navigator and navigating that manually while I screen captured the screen. So that's how I actually got that animation. So yeah, cool. Anyway, they've sent a couple of USB gadgets. Yeah, so they've got the... That is very Japanese, is it not? Oh, cool. USB cable checker, always very handy, and a USB Bluetoothy thing, always very handy. Let's go to the bench. Aha, look at this. It converts USB keyboards, mice, and gamepad to Bluetooth. That's handy. I don't have any doodad like that. So yeah, that's going to come in real handy. And they really love their anime, don't they? I mean, this is just like, there it is. There you go. Go wild, all you anime fanboys. I'm sure you know who that is. Well, that's some serious screws on there. That's what she said. So, yeah, there it is. There's your Bluetooth module. Got a micro USB, not the more common USB-C these days. That's a bit of a bummer. But anyway, 4 buttons. You can pair device 1, device 2. You can select them, device 3, and pair. So I presume you can have 3 different devices programmed and you can just swap them. Bittrade1.co.japan, and this is their little flyer here. So we got these 2 bad boys up the top, but they've got a whole bunch of stuff. So what's a USB delegator? Yeah, a whole bunch of stuff. None of it in English, but I'm sure you'll figure it out. Heaps of different doodad boards. Link down below. There's the main board for those playing along at home. Nothing else on the bottom. Well, that USB cable checker is a tad more sophisticated than my one from the previous mailbag, which is just a bunch of dumb LEDs, but that one's like really good. Works really well. So, let's pull that out. Switch her on. USB cable checker 2. Nothing. I guess we have to plug in something, like a USB cable. Okay, I've got an unmarked one here, and it's thin, so... Whoa, hello. Whoa, hello. Shell short. Okay, let's plug her in. Green's good. Green's good. There you go. Oh, 169 milliohms. It measures the resistance. Wow. If I give that a bit of a wiggle, yeah. Doesn't change a lot. Right, so this is input A, input B, and you can see shell to ground short. So it's measuring the ground on that pin plus the shell. But then if I plug it in, you can see it's shell to ground short, both A and B. So both ends are grounded to the shell. Wow, this is really fancy-pantsy. And CC downlink and E-marked. Okay, this one's a real schmick. Like nice silicone one with big alloy connectors on it. Let's give that a go. Short, yep. And short, again, exactly the same. And of course it tells you there that's USB 2.0 standard there. It's not USB 3.2. Okay, a USB-C to USB-A here. So let's plug that in and see what we get. Could we, I assume we plug that into B again? Yep, USB 2 and ground short on B on the USB-C there. 235 milliohms. There you go. And there you go. It tells you we can source 0.5 amp there. Neat. And there we have it. We have a USB 3 one. And like you can tell, like this is big, like thick as here, right? And yeah, all green, all good. I really like this. Wow. How much is this? Doesn't matter. It's probably worth every cent. Okay, I've got a keyboard plugged into this USB doodad here, and there it is, USB to Bluetooth. So let's try that. And now I have a keyboard. Awesome. Works. We didn't win a chicken dinner. Well, there you go. We're 2 for 2 on these products here. So yeah, I'll link in their website down below. Thank you very much, Bittrade1, for sending in these useful gadgets. They're going straight to the useful USB gadget bin, and as in good bin. Hi to all my viewers in Switzerland. Thank you very much, Matthew Berger. And it's a book. It's a book from Amazon. Has Matthew written it? I don't know. We'll find out. Let's have a look. Sorry, it's been here a while. Oh, we do actually have a note. Oh, excellent. Professional electronics design best practice. Matthew has written this. Look at this bad boy. It's a comprehensive collection of best practices in circuit design, schematics and layout examples, more than 100 diagrams, more than 30 tables with practical, useful information. Sorry, Matthew, this one's actually been sitting here for an embarrassing amount of time. So Matthew's written this. This is the book I would like to have had as a young engineer. 25 years later, I wrote it myself for the young engineers of today. It would be great if you could mention it. It is available from Amazon self-publishing. Thank you very much. Yeah, these days, so easy. Well, it's not easy to write a book. Very easy to get it published, and you don't have to publish it. You can just do self-publish, publish on demand. The Amazon book printing thing, like this is probably, this would be printed on demand from the Amazon thing. Fantastic. So you don't have to have inventory, upfront NRE costs or anything like that. So yeah, it's just your time and your blood, sweat and tears that goes into writing a book like this. So let's give it a quick check out. I won't show you obviously through every page. Lots of nice diagrams. Excellent. It's all in black and white. None of that color rubbish. You don't want to waste your money on any of that. Nice. Professional Electronics Design Best Practices, Matthew F. Berger. Comprehensive collection of best practices in circuit design, schematics, layout examples, more than 100 diagrams, 30 tables, practical, useful information. The electronic rapid prototyping ecosystems available today, which include an extensive collection of code libraries and examples, seem to make hardware and firmware development easier than ever. They do indeed. This belies the fact that a working rapid prototype is still far from production ready. The secret to a successful professional electronics design is not just about its functionality, it's also about getting everything else right. Wise component selection, proper power supply design, electromagnetic compatibility, fast signal routing, thermal management, testability, and the list goes on. This is where this book comes in as a collection of best practices in the above areas. And here you go, from the index, you can see that there's basically, a page or less on each different there's a ton of different things, diodes, transistors, optocouplers, op amps, reference voltages, memory selection, ADCs, DACs, microcontrollers, watchdogs, low-level programming, all sorts, even simple stuff like buttons and resistors and stuff like that. Direct current power supply design. So you've basically got like a short little, for one page or half page snippet on each and every different thing. Robust interfaces, ESD protection, signals on, so it's got some PCB stuff in there, although it's not a comprehensive PCB layout guide, thermal management, testing and verification. Good stuff. Anyway, I can't possibly show you it all. So there's quite a few pages on ESD protection. Let's go there. So ESD, for example, starts out with an example of a real chip that you've got. It's an angle sensor, and, well, how do you want to protect that? And we're going into, it's got human body model stuff, the IEC standards and things like that. I might do future videos on this now that I have a real ESD gun that can actually produce these proper human body responses and the IEC response like this. So we've got ESD protection for CAN buses, talking about line protection using series resistor and diode. We've got an avalanche diode here without resistors. For instrumentation amplifiers, talking about leakage current. Yep, that's what you've got to take into account. That's a big deal. And even cheap ESD protection using a capacitor. Neat. And it goes on about surge protection, so that's a reasonably comprehensive little section on just ESD protection. Got over voltage on long cables, going to burst and surge protection, earth potential discrepancy, and then we go into interference stuff like this. So this is, I don't want to show you the whole book, but then we get into chokes and stuff like that, using 3-terminal caps. Excellent. It's just a little thing on charge pumps here and how, well, should you actually use charge pumps, for example. And, well, you can actually make your own to do a couple of milliamps, stuff like that. I've done videos on this, and he's basically saying, yeah, you can, but if it was any good, everyone would do it. And, well, they wouldn't sell the dedicated chips that do it if it was just easier and cheaper to roll your own. So often it's not. Very brief section on layout and using the example of a DC to DC converter here. So that's pretty good. But as I said, it's not comprehensive. You get a page or two tops on each little topic. So it's more like a hints and tips type thing than it is for like a, reverse polarity detection, for example. It's a short little, hints and tips type thing rather than a comprehensive tutorial like, choosing field programmable gate arrays. There's like a page and a half on that and then some notes on some clocking and stuff like that. And for the power supply decoupling and power plane aficionados, it goes into some detail on that. Actually, it's not bad. Decoupling capacitors and the time domain and stuff like that. So, but once again, not an absolutely comprehensive tutorial on it, but it's just, hints and tips here and there. Oh no, tracks at right angles, busted! Nice little tips like how to avoid heat sinks, thermal vias, for example. And then we've got the practicalities, operating points of fan flows. I've done some stuff on that, but, nice little things. I like it. Little tips on how to measure the temperature of dyes, for example. There are some things that are lacking though, like the op amp section, for example. It really doesn't go into detail on much at all. As I said, like a page and a half on like op amps, could have, done with some more useful tips there perhaps. So whilst it does cover an insane amount of stuff, and really these sections are, really stuff that you need, robust interfaces, PCB signals, thermal management, testing and verification, all really important stuff. And some stuff does get a decent treatment, but probably one of the downsides of it is that some things that I was hoping for more treatment just didn't go into detail there. But, always an expanded edition in the future, I guess. But that's not bad. I actually like the concept of this thing, just giving you short, practical tips on various things without going into, heavy theory or detail. Just short hints and tips that might actually spark you to do further research or at least consider things that you may not have considered before. So I like that. Well done, Matthew Berger. I'll link it in down below. It's print on demand from Amazon. I'll see if there's probably a Kindle version available as well, I guess. There is for everything these days. Well, it's almost the same price as the printed version. Yeah, give me the dead tree. Another one from the United States of America. Thank you very much, Christopher Hop, I think it is. It's sort of obscured by the postmark in Wisconsin. Madison, Wisconsin. I think it's Wisconsin. Oh, it's already open. Sure, I haven't had a look at it. Huh? Let's have a look. Ooh, look at that. Oh, maple. Organic maple candy. Yummy. Thank you very much. Hop's Brain, pronounced Hoppy's Brain. Okay, Hoppy's Brain. We've got some large, very large transistor packages. Looks like we might have a blown-ass transistor here. Is that blowing? I don't know, or it's cut away or something. We can have a look inside the die. This is interesting. Let's go straight to the bench. There you go. You can scan that if you're playing along at home. Hello from Madison, Wisconsin, from Hoppy's Brain. And this MT200 transistor package has an absolutely huge heat spreader, making it ideal for pulse duty applications like audio amplifiers. Large copper mass moves the heat away from the die with quickness, with haste, and spreads it out before it can get to the slower conducting aluminium heatsink. Copper has about twice the thermal conductivity of aluminium. There you go, the figures for those playing along at home. MT200s are typically rated for an additional 50 watts over the same transistor die in a TO3 plastic package. As you can see, the Sanken MT200 is literally just a TO. Well, okay, so we definitely have a MT200 fan package fanboy here, and this is a very nice cutaway. Many techs just bodge a TO3P transistor in place of the MT200, and Bob's your uncle, right? But yeah, not so fast. Oh, yeah, he literally says not so fast here. It has 3 times the heat spreader contact area of a TO3. Wow, he's really selling the MT200. If you're not convinced about the MT200 after this, then, well, there's something wrong with you. He's designed these adapters, which are basically the same thing as an MT200, a TO3 soldered onto a large copper heat spreader, direct heat sink copper PCBs are pads that are solid copper all the way through. No dielectric layers to get in your way. So there you go. So what he's come up with is this little adapter here, and we'll take a closer look at it. Basically, it's on a big copper base plate, and you can mount a TO3 or a TO247 transistor on there, and then screw that into your product, and you can get much better thermal transfer. Nice. So you can avoid like hot spots in your die, for example, and the magic smoke venting. So anyway, that's really, oh, cool. What's this? Okay, we have a metrology joke, so I'll just leave that there for you to ponder. So there you have it. Here's the little copper adapter PCB. You can see that's just thick as. There's nothing else in there. This isn't your regular PCB. Look at that big chunky bit of copper, which is going to spread the heat way, way better than just mounting the same transistor directly on your PCB. So this Sanyo MT200 package is literally just a TO3 heat spreader soldered to a larger heat spreader thing on there. So there you go. So you can see it. It's just soldered onto that larger thing. So the larger package is essentially just a smaller package, but soldered onto a heat spreader. And that's what he's basically duplicated here with this. So you can roll your own MT200 package. Neat. Anyway, so I'll link in Hoppy's Brain website down below. It's literally hoppysbrain.com. That's very cool.